Hello everyone, welcome to Amazon Web Services Machine Learning Operations with AWS Masterclass, and this is day 22 of Machine Learning Operations with AWS, and I welcome you all on behalf of pantechelearning. And today we are going to see the fifth project. So in the previous class we have discussed about the base things and the pre-processing, how to handle the text data, which is like NLP task, right? Natural language processing, how to convert it into numerical format. Till that we have done. And today what we are going to do is we are going to make predictions with that. So we'll be going into the machine learning part. We'll be taking a data set, do all the pre-processing which we have learned earlier, and then coming back here, join it with algorithm, try to make it do a prediction. And then what we are also going to do is we'll just see some base about what is a RNN, what is LSTM, and then we'll try to use that neural network also along with machine learning algorithm. We'll try to go with that neural network also for prediction. That's what going to be our today's agenda. And we are going to see the fifth project, and the fifth project we are going to see is nothing but women's e-commerce clothing reviews using NLP. So what we are going to do is we have a data set where we contain women's e-commerce clothing reviews. So we are going to take that data and work on it. For example, what is the introduction of this data set particularly is women's clothing e-commerce data set revolves around the reviews written by customers. So it's like it have 9 features. So it's a great environment to pass out the text through its multiple dimensions. So because this is a real commercial data, it's a real world data. So what they have done is they have anonymized and reference to the company. Like for example, if someone is giving review, so they used to write about like the cloth and the brand of it. So whether it is good or bad. Since it's a real world data set, they have anonymized and like reference of the company or the user. They have changed it with names such as retailer. To be anonymous with that. So that's what will be available in this data set. And the objective for us today, so the objective here is to create a classification model which can classify the given review text as positive or negative. You can do it with machine learning algorithm or neural network, but the primary objective here is to do that. And so we'll go hands-on with the project and see till the machine learning part, and then we'll come back into the basics of RNN, and then we'll learn how to build a neural network and try to do the same task there. So let me just go and open, and so this is what we have. So let me first import pandas, numpy, matplotlib and seaborn, which are the necessary libraries, and let me load the data set which I am having in the S3, and let me go with the head. So this is my data set is so I'm having some null values inside, and we have some column names. This is unnecessary, ID is unnecessary. We have age column, the title, the review text, the rating, recommended IND, positive or feedback count, the division name, what dress it belongs to. And that's what the data set we are having, and we can focus on the rating. So we have rating from 1 to 5. So that's what we will be focusing on. And the review text, we are having the text here. How much they are writing about it, that's what the text is going to be. So I think these two are unnecessary. We can focus on these things after 2. So I can just take that alone. The columns which are present after the second one, which is starting from age, title, review text, etc. And you can go and analyze one by one, and we can find a lot of null values here. So I can see, like in the title I'm having 3810. And the review text I'm having 845, let it be. And let me go with data.shape. Totally we are having 23,000 rows, and nearly 3,000 is null. And we can also go and check for the next things, like what are the ratings available. So totally the ratings we have 5, 4, 3, 2, 1. So this is our target variable. This is a multi-classification, but we won't be going with a multi-classification kind of approach here. So what we'll be converting is we'll just mingle this 5 and 4 as a positive review and 1, 2, 3 as a negative review. And still if you go and add this 1, 2 and 3, you will get something around 5,000, and here if you go and add both of this, you will get around 18,000. So once again, if you have this as a binary classification, then what you can see, you have positive, which is 18,000, and you have negative category, which is around 5,000, which clearly says what kind of issue, guys. Tell me, guys. Okay, what kind of issue is there? It is an imbalance in the data set is available. So here, in the previous project, one project in the vehicle insurance claim fraud detection, we had the same imbalance, but we went for something known as undersampling, where I have like one minimal group and one maximal group. Okay, like the positive and negative. Positive is many and negative is very less. So what I have done is, in that case, I have gone for undersampling, which means I am taking sample from the highest one. I am just picking some parts of it so that both can be equal, right? Here we will be using another approach, which is resampling or oversampling, where we will keep the positive as same and the negative is manipulated by the algorithm itself. Okay, we have some tools for it, so it will create its own so that everything can match. Okay, and we'll go with other things like what is the recommend index, first tip feedback count. It's the most repeating one. We have a lot, and positive feedback count, we can see like mostly it is around 0 to 20, and we have some value which is around 120. And yeah, the columns, and these are the columns. We have like other columns, right? We have like we are accessing it one by one and seeing how much it is distributed. And like let us take this division name, department name, and class name, and then we'll go and get the value counts. So this is the like what type of dress it is, and they are like splitted it into parts, and you can see what all things present there here. And what is the thing we are going to focus is, see here once again, before going into this one, we have a lot of things, we have a lot of details. Okay, let me just go with head. So we have age column, we have title, review text, etc. So we have other divisions also. So what is important here for NLP task, our title and review text may be important. Okay, and this title we are having a lot of null values. Some may give title for their review and some may don't. So what I'm going to take is, I'm going to consider the review text alone. Okay, this is my important thing. And we have the rating, okay, which means this is the label, this is the feature. Since it's the text, you can go with this column alone. So what I'm going to do is, I'll take these texts and I'll encode them in some format. Okay, I'll do NLP task, and the rating is the label. I can just map to it, right? So I'll just convert them into positives and negatives, and then what I can do is I can categorize them, so this can match with that. Okay, and other things you can go and use that too, so that's up to your wish, and try to build a model which we can go for further prediction. I'm just going to minimize it with this review rating, review text, and rating. So my new data is going to be these two. Okay, and yeah, data 2 equal to data review text, comma, rating. Okay, so let me just go with the head, data 2 dot head, and this is my data set. Okay, I'm going to just focus on this. So what you can also do is, you can just remove, like where null value in the title, you can remove those entire rows, and then what you can do is, you can add this title with the review text, or you can keep that as a certain column and then go for like converting it into numericals and then process it. Okay, that's complex and you can do it on your own wish. It may or good or bad, so based on the data we are having. And here we are going to take these two, one is review text and another one is rating. Okay, and here if you go and check for null value, we know that review text is having some kind of null, right? So around 800. We'll just check it once again. So we have 845 null values here in the review text, so we cannot do anything with that, so I'll just drop it. Okay, and if we check it once again, now everything is 0, and totally my shape now is 22641 comma 2. Okay, 2 columns and 22,641 rows. So let me just start with our next step. We have our data set. Okay, now what you can also do is, let me just show you guys, data 2 dot, okay, I'll take view text. Okay, so you can go and check like what is present there. For example, if I take this, so this is the text I'm having in the third row. Okay, so it seems like some positive comment, and you can go and explore that. Okay, and we have a lot, right? 3000 is also there. Okay, so they have written a lot like this. So in every row we are having many reviews they have given, and we have our rating, which I'll just convert it into positive and negative further. Please wait. Okay, and totally we are having like this, right? So we want to go into each row and do some processing, and since it's a human text, you know what all the pre-processing you should do. You need to remove punctuation, you need to remove stop words, you can go for like stemming or lemmatization, and then you can go for TF, IDF or bag of words, right? That's what the hierarchy is going to be. So let me start with pip install NLTK, and I already have it, so the requirement is already satisfied. And once again, to go safe side, I'll just install or download all. Okay, so like I have done it already, so if you haven't, like it will take some time and it will download. So once you are done with that, let me just go and call it once again. So this is my data set. Okay, and if I use this one, see here, okay, I can use for index location. Okay, so I'm just using the index location and getting the 0. What is the 0th? Is the entire thing, the review text and their detail. And if I call 0 here, it will give me the answer here. So if I go for 1, I'll get the next one. 2 here, I'll get the next text. So this is the format. Why? Because I'm doing this, I'll be using it in a for loop. See here, I'll just import from nltk.corpus, import stop words, and the stop words is English. Import nltk, and this is for just doing the punctuation. Okay, so yeah, first we'll go with this one. These are just splitted parts. So yeah, I think we can go with this one. Okay, so what I'm doing here is, see here, this is what I have done right here. If I use index location, okay, so if I go and get the number like this, whichever I am locating, it is giving me the entire thing. So if I want the data alone, I can pass the 0th index of that, so it will give me the data alone. So I can pass it one by one. Okay, so whichever number I am passing from like 0, okay, the index it will take and give me the output. So that's what will happen. So what I'm going to do is, I'll go and check the shape of it, and we know we have 22641 totally. So I can go and run this in the range of 22641. Okay, so I'll just create like remove this, like the final output here in a new list. Okay, and the content I'm going to take every time the loop runs, it will start from 0 till 22641, the last text we are having, and take the entire words. And then I'll call it to tokenize. Okay, word, it will be splitted into words. Okay, this will contain a list which is splitted into words. So for C in that, okay, every word I'm going to iterate, and I'm going to check for stop words and punctuation. So I'll just remove them, and then I'll add. Okay, and then whatever the input I'm getting, okay, I'm just directly stemming it. Okay, you can go for stemming or lemmatization. I'll just stem it and then append it in this stopped. Okay, and once it is done, what I'm going to do is, I'll just store the same in the same place. I'll just replace it by joining them. I hope it will be clear. Once again, I'll tell you, if I use this dot ilocate and pass the number here one by one, it will give me the row, and if I go for 0, it will give me the text alone. I am using a for loop in the range of the whole number. So what will happen is, from 0 to till the last number, it will go and take the content. Okay, and just converting them into words, and using a for loop one by one, the word will go inside of it. And if the word is not present in the stop words and punctuation is not present there, it will pass it to go inside where the C. What I'll be doing is, I'll just stem it directly and I'll just append it. Okay, and whatever I have appended, it is going to be joined into a sentence and added in the same location. Okay, so it's taking the sentence, doing all the process, and like replacing it in the same place. So if I run this is going to take a couple of seconds, and it will give me an output which is all of these things have been completed. Okay, we'll wait for it to complete, and it's completed now. So what we can see is you can go and check the head of it. Okay, like this is what we are having, the output, which is like stop words has been removed. Okay, and all the process has been done, and it has been replaced in the same place. Okay, so what you can do next is, we have to handle the rating. Okay, rating is important here. What I'm going to do is I'll create a new column which is called as label, where I'll just see the rating. I'll map it. Okay, if it is 1, I'll just turn it into negative. 2 is also negative. 3 is also negative. But if it is 4 and 5, I'll just turn it into positive. So if I go and run this and get the head, we can see the label is positives and negatives. 4 and 5 will be now turned into positive, and 1, 2, 3 are now negative. So this will comes under a binary classification and we cannot give this text entirely, right? So I'll just call the label encoder to fit and transform it. Okay, and this is what my label is having, and this is what totally I'm having. So as we have discussed earlier, the positive count 1, okay, it has been represented as 1. It is 17,400, and the 0 or negative count is 5,000 only. So there is a huge imbalance here. So what I'm going to do is I'll just collect the positive data. Okay, 2.label, wherever the label equal to 1, which means it's a positive data. So these are the positive data I'm having. Similarly, whichever not equal to 1, which is obviously a negative data, I'll get the shape of it. Here we have 5,193. This is 17,000, right? So when we go for the previous project in the vehicle insurance claim fraud detection, we went for undersampling, where here I have 5,000, right? So what I can do is I can go and take 5,000 from this and do the next process. But here I can go and resample. What it will do is it will increase this others. Okay, it will manipulate the same things in addition. Okay, so that both can be in the equal length. So what I can do is from sklearn.utils, you can import resample. Okay, and the others oversample is resample. I'll pass the others is the minimal one, and replace equal to true, and the whole number of samples is how much I need till the positive length, which is nothing but 17,448. So if I run this, I'll get everything which is now 0 in 17,000 places. So we'll wait for it to load, and we have in 17,448 places. In this others underscore oversample data set, I'm having zeros only. So I'm having 17,400 zeros and 70,400 1 here. So what if I can do is I can just concatenate them, and now totally if I go and see it, I have a label of 0 and 1. If I check it, I have a total data set of nearly 35,000, where equally balanced data I'm having. So this is a kind of sampling technique. Previously we have done undersampling, this is oversampling, and once again the head counts. So we have done the pre-processing, and we have created the label. So label will be our feature, and review text will be our feature, and label will be our target. So you can just map it. So let us call from sklearn.feature underscore extraction.text. We can import TF-IDF vectorizer, and TF-IDF vectorizer is nothing but to convert them into numerical format. It will take the term frequency and inverse document frequency and take a dot product of it, and it will assign weight to everyone. So what you can do is you can create an object for it, and you can set some max features. Okay, these are like many things, right? You don't want to go complex with that. You can like keep it around 3,000, 2,500, etc. Okay, and this is usually 1,1, so just ignore it. And what you can do is you can call this vectorizer to fit and transform. In this data 3, I need to take this review text alone. Okay, right, we need this review text alone to be encoded, right, using TF-IDF vectorizer. So you can just call it directly, and it will be a sparse matrix. So if I go and print the vectorized, you cannot see it actually. It's a sparse matrix of NumPy. You can just turn them into an array. So if you want to see it, the shape of it, you can go check it. Totally we are having that 34,896. This total things is like it is kept. Okay, just converted into numerical shapes, etc. Okay, I can go and get the X also here, capital X. Okay, so in between it has the numbers which have important things, etc. And in Y we have data 3 dot label, right? So, and that I need the values alone, I can go and get that. And what I can do is from sklearn dot model selection, I'll import train test split. Okay, and I can pass with 0.2 and random state as 0. And yeah, so you have multiple classification algorithm. You can go for like naive Bayes classifier or AdaBoost, XGBoost, decision trees, etc. I'll go with AdaBoost classifier. Okay, it's an ensemble algorithm, right? Boosting algorithm. And yeah, before going into that, I think Y train is already, yeah, we don't need this now. We can just go directly with this one. We'll wait for it to complete. Okay, some internet issues, so the kernel has been disconnected, so I'll just restart the kernel and I've run everything from the above. So we'll wait for it to complete and then we'll continue with the class. Okay, these things are not necessary. Yeah, this punctuation is missing from. Okay, I'll import string punctuation equal to string dot punctuations punctuation. Yeah, now it will run properly. The stemma. Equal to porta semma. I think I have deleted it in between. Stemma, the name, yeah. So let it complete and let me run till this one and then we'll continue with it. Yeah, so it's completed. I think we can go and run the next one. Yeah, continue with this one. The labels, encoding. And the TF-ID factorizer. Yeah, AdaBoost has been imported. Now we can continue with the model building. So I'll just fit the X train and Y train and let it ask to predict the X test value. Okay. So we have splitted like the same thing as we have the data, we'll just split them into parts and then give it for X train, X test, Y train and Y test. Okay. And like once the fitting has been completed, which means nothing but the training part is completed, we can go with the other things like testing it, etc. And then we'll continue with the neural network. So we'll wait for this to complete and wind up. And yeah, once it is done, we can go and call. We know, right, we have confusion matrix or classification report and accuracy score to verify how good it is performing. We can do that, and you can go and use some other algorithms too. So we'll wait for this to wind up. Yeah, it's done. So let us go and check the answers. Yeah, we have zeros and ones. Predictions 0, negative, 1 is positive. So I'll import the necessary matrix and report and score. So the classification report I am getting is the 0, like both are 0.80 precise, like equal importance they have achieved, and the accuracy score is around 0.79, which is equal to 0.80. That is like okay with this model. You can go and search or change the model with this and search, and like totally we are having 50% right overall. So in this way it is actually performing good, not biased towards any side. And you can also get a confusion matrix, and this is what a confusion matrix is looking like. One predicted at 1 in 2800 places and 0 is the same, nearly like somewhat equal. They have correctly predicted and wrongly predicted too. Okay, so you can change the algorithm and verify and improve it, and you have other options also like a neural network. And when you go for a neural network, what you can do is when you have this kind of text data in NLP task, you can go and use a RNN network. So what is a RNN? We'll see about it now. A recurrent neural network is a type of artificial neural network that is designed to work with the sequential data such as time series or natural language text. So these are sequential data, right? So what is the word you are speaking first and the word you are having last in a sentence may have connection, they may have meaning. These are sequential things. Like a time series, like for example, you have like if you have stock data or etc., those also can be used with RNN. So the basic idea behind RNN is to use feedback loop to propagate information from one step to the next. So with the output of each time step serving as an input to the next one. So what will happen is every time it runs, okay, it will give a feedback to the next one. The neurons, it will get a feedback so that the information can be passed on from one to the other. So this is what a major advantage of RNN is. Okay, it's not a back propagation. We have back propagation, but every time a loop runs, okay, this one it will give a feedback to the next one. Inside of it, they will pass feedbacks. And RNN have found numerous applications in areas such as speech recognition, language translation, and time series forecasting, etc. So this is what a RNN will look like. So when a neuron they does some task, it will give some feedback to the next one. A feedback is passed, okay, a feedback is keep on passing to the next layer, and okay, so the input is in the form of a sequential data that is fed to the RNN, which has hidden internal state that gets updated every time it reads the following sequence of data in that input. And RNN, we have like it will pass the information from one step to other, and we have some drawbacks of RNN. So we have something like vanishing gradient and exploding gradient problems. So these two are like two contrasting things. For example, what is a vanishing gradient problem in RNN? So when training RNN, the gradient of the loss function with respect to the parameter of the network need to be propagated back through time, which can lead to problems of vanishing gradient. And this occurs when the gradient become very small as they back propagated through many time step, okay, making it difficult. So what is happening here is, okay, we have two kind of problem, two contrasting things. We have exploding gradient also. So what will happen is when you have a very large during back propagation, the parameter need to update too quickly and leading to instability. So see here, every time this one is performing, it is going to give a feedback, right? And this feedback is keep on adding so that when a back propagation happens, the clumsiness or the noise is keep on getting added. So this may lead to exploding gradient and sometimes nothing will happen. That's called as vanishing gradient problem. So these two like problems are already there. So to avoid this, we have a modification of RNN or a type of RNN which is called as LSTM. So it is like long short term memory. So here we have memory, which is the information is passed, but it is long and short term, which means this will forget some things. Okay, so if to avoid the exploding gradient, which means like the things keep on adding so that it become unstable, right? So to avoid that, we have LSTM, which is long short term memory. To solve the problem of vanishing and exploding gradients in RNN, many variations were developed, and one of the most famous of them is the LSTM, long short term memory. And LSTM stands for long short term memory network, used in the field of deep learning. So it is a variety of RNN that are capable of learning long term dependencies, especially in a sequence prediction problem. Okay, they will carry some information. At the same time, they will lose some information to avoid this kind of noise from the data. Okay, so this is what the inside of like a sample how a LSTM will look like. And in LSTM we have multiple gates, a memory gate, a forget gate, etc. We'll discuss about that. And we have a forget gate, a input gate, and a cell state, okay, output gate. Every time information passes, it will like pass through these states where it can be added or subtracted based on whatever the task it's performing. So what will happen is these are numerical things, right? And whenever it passes the information, okay, if the data which is like connected with the previous one, it will be a sequence and it is important that it will be passed through the memory gate and it will be stored. And sometimes if the data is not that much important, okay, like if there is no relation between this one and the previous one, then it will pass through the forget gate. So the unnecessary things will be left out and only the necessary things will be added. Okay, and it can be done by a point by point addition and point by point multiplication. So at each time step t, an LSTM cell takes in an input vector x of t and the previous hidden state x of t minus 1 and the previous memory cell. Okay, whenever LSTM takes an input vector, along with that it will take the hidden state and the memory cell of the previous one. So these inputs are used to compute the input gate, forget gate and output gate, and it will determine what is the value of the output should be. So the input gate determines which element of the new input should be added to the memory cell. We have input gate, forget gate and output gate, right? So input will determine which element of the new input should be get added to the memory cell, and the forget gate determines which element of the previous memory cell should be discarded. Okay, whichever not important will be discarded in the forget gate, and the output gate will determine which element of the current memory cell should be output of the current time step. So it will like lose some information and it will carry some information. So that's why the name long short term memory. And yeah, so we can build this, we can call it from Keras, we can use LSTM layer. And before going and using LSTM, or we have a sequential data, guys, text data, it is number format. You know, right? For example, see here, and I go and show you, my first text may contain, okay, they have like some small text, okay, this will be in one line, and we have seen something is around 4 lines, and they are different in their shape. And remember, whenever we went for a neural network, in the image also we have mentioned the input length, which should be standard. We cannot have multiple lengths congested, okay. And to do or to avoid any issue with that, we'll be going something known as padding sequence. So for example, if you have a sequence 1, 2, 3, 4 and 5, they are in different size. You can make them into a single size by using padding, which is called as like pre-padding or post-padding. You can go with zero padding. And in zero padding, what will happen is if you go for post-padding and at the length of 7, so the overall the length will be fixed as 7, okay. And like what will happen is the extra spaces will be filled with 0. It's like padding, we have done it image, right? Here also the same, but it's like pre-padding means zeros in the front, and post-padding means zeros added in the end. And we can go and do that. Okay, this is one of the pre-processing you need to do before going into this one. Okay, so yeah, here also the same thing. I'll just convert it back into an array, tf-idf, yeah. And then from keras.processing, pre-processing.text, you can import tokenizer, and from keras.utils, import pad_sequence. So we'll be focusing on this tokenizer is same like we know in NLTK, right? The same sent_tokenize, and I think we may not using it here, but this one we needed pad_sequence from utils, and the maximum length I'm setting is 15. Okay, I'll pass it inside, and the padding is pre-padding. Okay, you can change the length to, for example, I'll change it totally as 30. Don't worry, we have some lot of information inside. Let us not lose information. I'll go with pre-padding, and the maximum length is 30. And once it is done, you can just like we are storing it in X. Okay, we already have Y. I'll just turn them into array. Here also I'll just turn it into array and go with X train, X test on Y train, Y test. In the different name, validation, train, etc. Same. And from TensorFlow, Keras, we need sequential, okay, dense layer, relieve, and dropout. Okay, and what you can do is dense is the like sequential is for building the network. Dense is the layer, right? You can add neurons in it. Relieve, okay, and dropout is something like you can add it in between if you want to avoid the overfitting. Okay, some information will be left like every time a layer passes out. And yeah, it's time for us to build. So since I have changed the length, I should go with 30 here. Okay, and since if you are using in AWS, I'll just suggest you guys to go and import or write these 2 lines. Same thing in CNN also. And in like whenever you are building a neural network, you may get some error like NHW or something like that. And to avoid, like, it's the channel, okay, you can just call the backend and set the data format as channels lost. And the sequential, LSTM, dense, and embedding layer is important to, like, I'll tell you the hierarchy. First, the size and vocabulary size. Before going to that, see here, I'm calling the sequential in model. I'm adding before going into LSTM. Okay, previously in image we have gone for convolution 2D, right? Likewise here you want to embed it. Okay, so whatever you have padded, you have to first go for an embedding layer, and the input size is the total vocabulary size. Okay, I'll go with 10,000 words alone, and the output dimension is the embedding size. I'll go with 200. It will just do the embedding to this format, and the input length is 30. And then I can build other, like I can go and have multiple networks. Like for example, I'll call an LSTM with 100 neurons and a dense layer, okay, which is the output layer. Like you can have multiple layers inside. I'll just go with the base one, and the activation is sigmoid because it's a binary classification. And again, you can just do it single line, like compile with loss as binary cross entropy since it's a binary classification problem, and the optimizer as Adam, and the metrics is accuracy. I'll print the summary and then fit it here itself. With epoch, I'll just go with 3, and if you increase the epoch, it will like keep the time. With the time increases, the training also increases and the output may improve. Okay, and let us run this, and it's building, and the epoch has been started. Okay, so we'll wait for it to complete. And below that, what I have written is, it's like I'll ask the model to predict the x test, which is x value, it's the same thing, and it will be giving me the probability. So I'll just go with a threshold value of 0.5, and I'm just rounding it off as integer. So if it is greater than the threshold value, it is 1 or 0 will be predicted, and with that I can just go and compare it with my original answers. Okay, so at first we are having around 0.5. okay, so with epoch increases, the training increases and the data may increase. And yeah, let us wait for it to wind up the 3 epoch, and you can try and play with multiple parameters here. And once again, what we have done here is we have went for the review text alone. You can include the title also, or you can go for further columns also for making the prediction. Okay, you can go and include these two, right? And these will add further feature which may or may not important. But for NLP task, if you go and handle as a NLP, then the title and review text may play a huge role, especially the review text, because the text and title will determine the idea behind it, right? Whether it's a positive one or a negative one. So what you can do is you can build a system. If you pass the data, it is going to give you whether it is a positive one or a negative one, which is 1 or 0. And yeah, next we got around 0.50, so it is increasing. And yeah, you can improve the epoch steps and try to get some good output. Yeah, it went deep also. Yeah, and let me call it to predict, and it is doing the predictions for the x test values, and this is a score around 0.50 has been obtained with this 3 epoch. Okay, and that's what about the NLP is. We have, once again, if you want a recap, we have took the important things alone. Okay, the text and the rating. We have done the basic pre-processing in a single for loop, which we have done in previous class. Okay, we have learned about things, right? Stop words, punctuation, stemming, or lemmatization if you want. Okay, and then we went into like mapping the output and categorizing them as negative and positive and encoding them. And then what we have done is we have done some oversampling, and we went for other things like TF-IDF vectorizer, and we have predicted with a machine learning model, and then we learned how to build a LSTM. Okay, just there, like hierarchy and the algorithm changes. Okay, in the neural network building, it is simple, so you can learn more about it. And yeah, we have get some output here. So that's it, guys. Thank you. So till now we have covered all the basics of machine learning, and then some advantages of machine learning, like you can go for deep learning, image classification task, or NLP. That's up to your wish. And yeah, shifting our gears towards the next part. So this course has been splitted into 3 parts, if you remember. The first part is the Amazon Web Services Cloud Essentials, to learn about the environment basics, and that has been completed around 4 to 5 days. And then we have started with machine learning. So I think it started in the day 5, and we are in day 22. Till now we have covered many parts of machine learning and some parts of like the base of deep learning and NLP. And our next ultimate step, okay, so this course is machine learning operations with AWS. We have to move towards machine learning operations. So starting with that, from the next class we'll be starting with Git and GitHub, and then moving into SageMaker, code build, code pipeline, and how to deploy it, and other AI services of AWS. That's what our next 8 days is going to be. And that's it, guys. Thanks for watching. We'll see you in next class with Git and GitHub.